Wi-Fi 1, the birth of wireless internet. The year is 1999. Wi-Fi 1 officially launched, and it was called 802.11b. This was the first time regular people could connect to the internet wirelessly. No more cables, no more being stuck in one spot. You could actually move around with your laptop. It felt like magic. Wi-Fi 1 worked on the 2.4 GHz frequency band. Think of frequency bands like invisible highways for data. The maximum speed was 11 megabits per second. Now that sounds super slow today, right? But back in 1999, it was revolutionary. You could check your email, browse websites, and chat with friends online, all without plugging in a single cable. But Wi-Fi 1 had some serious problems. The biggest issue? Interference. Here's what happened. Your microwave oven uses 2.4 gigahertz to heat food. Your cordless phone? Also 2.4 gigahertz. Baby monitors, Bluetooth devices, even some security systems. They all use the same frequency. So imagine this scenario. You're trying to load a web page. Your mom goes to heat up lunch in the microwave. Suddenly, your Wi-Fi drops completely. Frustrating, right? Another major limitation was the number of users. With only 11 megabits per second available, only 1 or 2 people could use the network. If your brother started downloading something, your connection became impossibly slow. Everything would freeze. This is why many people back then still preferred wired Ethernet connections. At least with a cable, nobody could accidentally disconnect you by making popcorn. But despite all these problems, Wi-Fi 1 proved something important. Wireless internet was possible, and it was only going to get better. Wi-Fi 2, speed but no distance. In the same year, 1999, another Wi-Fi standard appeared. Wi-Fi 2, officially called 802.11a. But it took a completely different approach. Instead of using the crowded 2.4 gigahertz band, it used 5 gigahertz. This was genius for several reasons. First, the speed jumped massively. Wi-Fi 2 could reach 54 megabits per second. That's almost 5 times faster than Wi-Fi 1. Suddenly, downloading files became quicker. Web pages loaded much smoother. And the best part? Way less interference. Remember how 2.4 gigahertz was crowded with microwaves and phones? Well, 5 gigahertz was basically empty. Most household devices didn't use it, so your connection stayed stable and consistent. No more drops when someone heated up food. Businesses and offices loved this. They could finally have reliable wireless internet. But here's where Wi-Fi 2 had a major problem. Distance. The 5 gigahertz signal couldn't travel far at all. Higher frequency signals struggled to pass through solid objects. Walls, floors, furniture, they all blocked the signal. Let me paint you a picture. Your router is in the living room. In that same room, you have blazing fast internet. But walk into the next bedroom? Nothing. The signal just disappeared. This made Wi-Fi 2 impractical for homes. People wanted coverage throughout their entire house, not just super fast internet in one room. So Wi-Fi 2 ended up being used mainly in offices. They could install multiple access points throughout the building. Problem solved for them. But regular home users needed something better, something that combined speed and coverage. Wi-Fi 3, the perfect balance. Enter Wi-Fi 3 in 2003, officially called 802.11g. This generation became a massive hit with regular consumers. Why? Because it solved the fundamental problem. Wi-Fi 3 used the 2.4 gigahertz band like Wi-Fi 1, so it had wide coverage throughout your home, but it delivered 54 megabits per second like Wi-Fi 2, so you got the speed too. This was the sweet spot everyone was waiting for. You could finally walk around your entire house and stay connected at good speeds. No more choosing between fast internet in one room or slow internet everywhere. But there's another reason Wi-Fi 3 became so popular. Backward compatibility. Wi-Fi 3 devices could work with older Wi-Fi 1 equipment. This was huge. People had already bought Wi-Fi 1 laptops, printers, and other devices. They didn't want to throw everything away and start over. With Wi-Fi 3, they didn't have to. Their old devices still worked fine. Manufacturers started producing Wi-Fi 3 routers like crazy. Prices dropped as competition increased. By the mid-2000s, Wi-Fi 3 was everywhere. Coffee shops started advertising free Wi-Fi to attract customers. Libraries offered wireless internet for students. Airports installed Wi-Fi networks for travelers. Working on a laptop outside your home or office became normal. This is the generation that made wireless internet mainstream. It proved that Wi-Fi wasn't just a cool tech experiment. It was the future of how we'd connect to the internet. Wi-Fi 4, the dual-band revolution. In 2009, Wi-Fi 4 arrived and changed the game completely. Officially called 802.11n, this was the first major breakthrough in wireless technology. The biggest innovation? Dual band support. Your router could now transmit both 2.4 and 5 GHz signals at the same time. Let me explain why this was revolutionary. Before Wi-Fi 4, you had to choose. Either use 2.4 GHz for coverage or 5 GHz for speed. With Wi-Fi 4, you got both. Speeds jumped dramatically. 300 megabits per second on 2.4 GHz, 600 megabits per second on 5 GHz. Here's how dual band worked in real life. When you looked at available networks on your phone, you'd see two networks, both from the same router but with slightly different names. One said Your Network and the other said Your Network-5G. Let's say your router was upstairs on the second floor. When you went downstairs to the kitchen, you'd connect to the 2.4 GHz network. It had a wider range, so your connection stayed strong even though you were far away. But when you wanted to download a game or stream HD videos, you'd go back upstairs near the router and switch to the 5 GHz network. Faster speeds, less interference, smoother performance. Finally, you had flexibility. But Wi-Fi 4 had another game-changing feature, MIMO technology. That stands for multiple input, multiple output. Before MIMO, routers used one antenna. They sent data, then received data one stream at a time. This created delays as the router processed everything sequentially. MIMO changed everything. Now routers could use multiple antennas simultaneously. They could send and receive data at the same time. Imagine a one-lane road upgrading to a four-lane highway. Everything moves faster and smoother. The connection became more stable. Speeds increased dramatically, and devices could maintain better connections even at a distance. Wi-Fi 4 became the backbone of wireless networking for nearly a decade. Many homes and businesses used Wi-Fi 4 routers well into the 2000s. It was that good. Wi-Fi 5, welcome to gigabit speed. Wi-Fi 5 launched in 2013, officially called 802.11 AC. This was a huge milestone because it was the first Wi-Fi to hit gigabit speeds. Wi-Fi 5 focused entirely on the 5 GHz band. Maximum speeds reached 3.5 gigabits per second under ideal conditions. To put that in perspective, you could download a full HD movie in seconds. Streaming 4K videos became smooth and effortless. Downloading massive AAA video games that were 50+ gigabytes, way faster. Wi-Fi 5 was built for the streaming era. Netflix, YouTube, Twitch, they were all exploding in popularity. People needed faster internet to handle all that video content. Wi-Fi 5 delivered. It introduced MU-MIMO technology, that's multi-user MIMO. Before this, even with regular MIMO, routers could only send data to one device at a time. Every other device had to wait in line. So if you had 4 people in your house all trying to use the internet, the router served each device one by one. Person 1 gets data. Person 2 gets data. Person 3 gets data. It cycled through continuously, but still, everyone had to wait their turn. With MU-MIMO, the router could send data to multiple users simultaneously. No more waiting. Everyone could stream, download, and browse at the same time without slowdowns. This was perfect for families. Mom could video call her work meeting. Dad could stream a football game. The kids could play online games, all at the same time without fighting over bandwidth. Wi-Fi 5 also featured beamforming technology. Normally, Wi-Fi signals spread out equally in all directions, like a light bulb illuminating an entire room. A lot of that signal gets wasted sending data where no devices exist. Beamforming changed this. The router could detect where your device was located. Then it would focus the signal directly toward that device, like a spotlight instead of a light bulb. This created stronger, more stable connection, especially useful when you were far from the router. The signal reached you more effectively. One important thing to remember though, these speed numbers are the maximum capability of the router. Your actual internet speed depends on your service plan. If you have a Wi-Fi 5 router but only pay for a 100 megabit internet plan, you'll only get 100 megabits. The router can't magically create faster internet. It can only deliver what your internet provider sends to your house. Wi-Fi 6, built for the connected home. Wi-Fi 6 hit the market in 2019 for a simple reason. Our homes got crowded. Smartphones, tablets, smart TVs, security cameras, smart speakers. Suddenly your router was juggling dozens of devices at once and everything slowed down. The 802.11 and AX standard solved this with a clever trick called OFDMA. Instead of handling devices one at a time like a delivery truck making individual trips, OFDMA splits channels into smaller sections so your router serves multiple devices simultaneously. It's like one truck carrying packages for 10 houses in a single trip. Wi-Fi 6 also doubled the simultaneous data streams from 4 to 8, so more devices get fed at once. The result? Real speed, up to 9.6 gigabits per second, but more importantly, rock-solid performance even when your home is packed with connected gadgets. The tech also cuts latency dramatically, meaning faster response times for gaming and video calls where lag kills the experience. Whether you're in a coffee shop, airport, or your own tech-filled home, Wi-Fi 6 keeps everything running smooth. Wi-Fi 6E, the uncongested lane. Wi-Fi 6E rolled out in 2021 with a game-changer, access to the 6 GHz band. By then, the 2.4 and 5 GHz frequencies were absolutely packed. Imagine a highway during rush hour where billions of devices are competing for the same lanes. Wi-Fi 6E opened a brand new, completely empty highway. This extra bandwidth means less interference and faster speeds, especially in high-density spaces, corporate offices, stadiums, university campuses, anywhere with tons of devices fighting for airtime. The 6 GHz band lets them operate without stepping on each other's toes. The catch? Not every device supports it yet. You need newer gear, iPhone 15 Pro, recent MacBooks, Samsung Galaxy Ultra phones, high-end gaming laptops. Older devices can't access that new band. Many Wi-Fi 6E systems also come with mesh networking. Instead of one router trying to cover your whole place, you get multiple small units scattered around. They work together seamlessly, and your device automatically picks the closest one for the strongest signal. This is a lifesaver in large homes or multi-story buildings where a single router just can't reach everywhere effectively. Wi-Fi 7, the speed revolution. Wi-Fi 7 launched in 2024 with a jaw-dropping spec, 46 gigabits per second. To put that in perspective, Wi-Fi 1 in 1999 maxed out at 11 megabits per second. That's over 4,000 times faster in just 25 years. But speed isn't the real story. The real innovation is MLO, multi-link operation. Before Wi-Fi 7, your device picked one band, 2.4, 5, or 6 gigahertz. You traded off coverage for speed. MLO flips that script. Now your device connects to all three simultaneously, combining their strengths into one super fast, super stable connection. No compromises. Wi-Fi 7 also doubles the channel width to 320 megahertz. Think of it as expanding a 2-lane road into 4 lanes. It packs more data into each signal with 4K QAM technology. And here's the clever part. When interference hits part of the spectrum, Wi-Fi 7 doesn't panic and disconnect. It smoothly finds the clean frequencies and keeps running without interruption. This tech is built for tomorrow. 8K video streaming, VR gaming with zero lag, cloud gaming, professional video editing. Your smart home runs dozens of devices without breaking a sweat. The downside? Wi-Fi 7 routers are pricey, aimed at tech enthusiasts and professionals. For most people, Wi-Fi 6 handles daily life just fine. From 11 megabits per second in 1999 to 46 gigabits per second. Today, Wi-Fi has exploded over 4,000 times faster in just 25 years. So here's my question. What Wi-Fi generation are you using? Let me know in the comments. If you enjoyed this, smash that like button and subscribe to TechBit Explained for more Tech Explained videos. Thanks for watching.